Hello and welcome back to our channel. Today we're exploring a fascinating question. Could Jupiter become a star? Now you might be wondering why we're even considering this possibility. Well, the reason lies in the composition of Jupiter itself. It's a gas giant primarily made up of hydrogen and helium, the very same elements found in abundance in stars. This raises the intriguing possibility of Jupiter transforming into a star. Now, let's take a step back and consider what we know about stars. Stars, those twinkling points of light we see in the night sky, are celestial bodies that generate light and heat from the energy produced by nuclear reactions at their core. They're powered by nuclear fusion, a process where hydrogen atoms come together under immense pressure and temperature to form helium, releasing an enormous amount of energy in the process. It's this energy that makes stars shine brightly in the sky. So given that Jupiter is composed mainly of hydrogen and helium, could it undergo this process and become a star? Well, it's not as simple as it might seem. For a celestial body to sustain nuclear fusion, it needs a certain amount of mass. The gravitational force from this mass creates the high pressure and temperature conditions necessary for fusion to occur. Unfortunately, despite being the largest planet in our solar system, Jupiter simply doesn't have enough mass to kickstart this process. It's estimated that Jupiter would need to be about 80 times more massive than it currently is to ignite nuclear fusion and shine like a star. So, while it's a captivating idea to imagine Jupiter lighting up our night sky as a second sun, the reality, based on what we currently understand about stars and planets, is that Jupiter lacks the necessary ingredients to make the transformation. Let's delve deeper into this and understand the process of star formation. Stay tuned as we journey together through the cosmos, exploring the mysteries of our magnificent universe. Stars come into existence through a process called nuclear fusion, where hydrogen atoms fuse together to release energy. Now, what is nuclear fusion? Picture this: in a vast cosmic dance, tiny atoms of hydrogen collide at high speeds in the heart of a star. When these atoms collide, they fuse together to form a heavier atom, helium. This is nuclear fusion, but this isn't just a simple dance, it's a powerful and energetic performance. As the hydrogen atoms fuse, they release an immense amount of energy, in the form of light and heat. This energy powers the star, allowing it to shine brilliantly and provide warmth to its surrounding planets. In the heart of our sun, for example, this process occurs. About 400 million metric tons of hydrogen are converted into helium every second. The energy produced powers the sun and provides the heat and light that sustain life on Earth. But it's not just any old hydrogen that can participate in this fusion. Only a special type of hydrogen called deuterium can fuse under the conditions found in stars. And the amount of deuterium in a star determines how long it can continue to shine. So we've got our hydrogen atoms, we've got our fusion process, and we've got our star shining brightly in the cosmos. But could this process take place on Jupiter? Well, Jupiter is primarily composed of hydrogen, the same element that fuels stars. It's a gas giant, and much like a star, it's made up of swirling gases and volatile compounds. However, there's a key difference between stars and Jupiter. Stars have enough mass and therefore enough gravitational pressure to trigger nuclear fusion. Jupiter, on the other hand, while being the largest planet in our solar system, doesn't have the necessary mass to ignite fusion. But could this process take place on Jupiter? Let's find out. For Jupiter to become a star, it would need to have significantly more mass to sustain nuclear fusion. Now this is where things get interesting. You see, Jupiter is a gas giant, primarily composed of hydrogen and helium, the same elements that make up stars. This is what sparked the intriguing idea of Jupiter potentially becoming a star. But it's not as simple as it sounds. In the grand cosmic scheme of things, Jupiter, despite being the largest planet in our solar system, is a lightweight when compared to a typical star. Stars, like our sun, are incredibly massive. This mass, or rather the immense gravitational pressure it creates, is what triggers nuclear fusion, the very process that gives a star its shine. Nuclear fusion is like a cosmic dance where hydrogen atoms come together under intense pressure and temperature to produce helium. This process releases vast amounts of energy in the form of light and heat, causing the star to glow brightly. It's much like the burning of a colossal hydrogen bomb, but in a controlled and sustained manner, giving the star its lifespan, which can span billions of years. But for this cosmic dance to commence, the stage, or rather the star, needs to have enough mass to create the necessary pressure and temperature. And this is where Jupiter, despite its impressive size, falls short. It's just not heavy enough. Jupiter's mass is about 1,000th that of the Sun. To ignite nuclear fusion and shine like a star, Jupiter would need to be about 80 times more massive than it currently is. So, despite its similarities with stars, Jupiter falls short in one crucial aspect. It lacks the necessary mass to sustain the cosmic dance of nuclear fusion. This means, at least for now, Jupiter will remain as it is, a majestic gas giant, the king of our planetary neighborhood, not a star. But who knows what the future holds? After all, the universe is full of mysteries waiting to be unraveled. As we continue exploring, we may yet stumble upon surprises that could rewrite our understanding of the cosmos. While it's an exciting idea to picture Jupiter as a star, the reality is different. Jupiter, the largest planet in our solar system, is a gas giant composed primarily of hydrogen and helium. These elements are key players in the formation of stars, sparking the intriguing possibility of Jupiter's transformation. Stars are born from a process called nuclear fusion, where hydrogen atoms fuse together to release energy. This energy powers the star, allowing it to shine brightly in the cosmos. It's a process that requires immense pressure and heat, conditions that are created by a large mass. Jupiter, for all its size and grandeur, falls short in this aspect. While it is the biggest planet in our solar system, it's nowhere near the mass required to ignite nuclear fusion. It would need to be about 80 times more massive to even begin to sustain the process. And even then, it would only form what's known as a brown dwarf, a celestial body that's somewhere between a giant planet and a small star. So as much as we'd love to imagine Jupiter lighting up our night sky like a second sun, it simply doesn't have the mass to pull it off. It will remain a planet, a gas giant that plays a pivotal role in our solar system. Jupiter's immense gravitational pull has a significant influence on the paths of asteroids and comets, often diverting them away from Earth. This role, while less flashy than that of a star, is crucial to the dynamics of our cosmic neighborhood. Jupiter's presence helps to keep our solar system stable and our Earth safe from potential collisions. It's a role that's uniquely Jupiter's, and one that it performs exceptionally well. As we can see, Jupiter's role as a planet is unique and indispensable. Jupiter is a planet, not a star. And it's a planet that we should appreciate for its own merits and the essential role it plays in our cosmic neighborhood. Thank you for joining us on this cosmic journey. We've explored a fascinating hypothesis, the potential for Jupiter, our solar system's largest planet, to become a star. We've delved into the composition of this gas giant, rich in hydrogen and helium, the same elements that fuel the stars in our night sky. We've unpacked the process of nuclear fusion, the powerful reaction that births stars and keeps them shining bright. We've also confronted the reality of Jupiter's mass, a critical factor in this equation. Despite its impressive size, Jupiter simply doesn't have the necessary mass to kickstart and sustain the process of nuclear fusion. While the notion of a second star in our solar system is captivating, it remains within the realm of science fiction. For now, Jupiter continues to orbit as a planet, exerting its gravitational influence and playing a pivotal role in the cosmic ballet of our solar system. As we wrap up this journey, we look to the horizon of our next exploration. Get ready to travel a bit closer to home, but still within the realm of the extraordinary. Our next video will pose another tantalizing question: could we colonize Mars? Prepare for a deep dive into the challenges and potential strategies for establishing a human presence on the red planet. From terraforming to technology, it's going to be an adventure you won't want to miss. Until then, keep looking up at the stars. The cosmos is filled with mysteries waiting to be unraveled, and we're excited to explore them with you. Remember to like, share, and subscribe for more intriguing insights into the wonders of the universe. Until our next cosmic journey, stay curious, stay enthusiastic, and most importantly, keep reaching for the stars.